bench of science, IIT Bombay. We are tailor-making these technologies, which are basically using woody biomass, waste wood, waste garden waste, things like that. We have been working on these technologies for past 15 years now. All these technologies which are in the research laboratories are coming into the kitchens of the mass cooking, where we are trying to replace. Right now we are replacing around 50,000 liters of fossil fuel, maybe LPG, diesel or kerosene. We are intending to do it to 5 lakh liters. This is going to help our national interest of foreign exchange deficit, and we are going to save a lot of resource to the country. These resources that we are talking are woody biomass. These resources are free of cost. Campuses like this, where there is a lot of greenery and waste generated, this will serve two of our national interests. I can say it can help our Swachh Bharat Abhiyan, as well as it can save us from the national foreign exchange deficit, I can say. These are the two things that can happen with these technologies that we have been promoting. These technologies are basically low cost. It can be as old model, you can call it, but with a lot of efficiencies and user ease. These technologies are at the cost of wood. I mean the price at which the wood is given, or for this campus it is going to be free of cost and with ease of LPG operation. So come, I will show you the technologies that are available here for use. We are working with a lot of research organizations still further beyond these things to get best technologies throughout the world to campuses like this and make them user friendly. This is our job. Thank you. Huh? This is a biomass-based water heater used for making hot water for various applications. It can be used for hot water, used for dishwashing, boiling of vegetables, many other applications where reheating of food also can happen. Also, it can be used for cooking of food. This is a hot water generated which is insulated from all sides by polyurethane foam. You need to feed hardly a kg of wood here, and you get 100 liters of hot water. Hardly 1 kg of wood is required, or waste shells like this, coconut shells, to light this. You put it here, close it off, light it off, you get 100 liters of hot water. Hardly 1 kg of wood will give us a lot of hot water, up to 100 liters of water in hardly 15 minutes time. This outside shell is insulated, so we get a lot of hot water outside, which is not touchable. This hot water cannot be touched. Right now, this is very hot water, which can be used for many utilities like dishwashing, cooking of food, cleaning of utensils, many other applications. This is a portable overhead tank. At sites like this, where portability or overhead tank connection is not possible, we have to fill up a bucket of water here, and we get a bucket full of hot water at the other end. This is a stored 60-liter hot water generator. This is very efficient. It is around 60% efficient water heater. It can be used for many applications. That's it. This is a fuel efficient dosa roti tawa. Whatever preparation has to be done on a tawa, this is the most efficient way of doing it. Here we have got the tawa, which has got fins at the bottom, which uses the highest heat absorption. Here we have got air ports, where we can supply the air, close the air for combustion. We have put around 5 kg of waste wood like this, which will do at least 500 rotis or dosas now. There is fin at the bottom, fins on top of the tawa, which will absorb a lot of heat. This is a 20 mm tawa of cast iron. It is fully insulated from all sides. Whatever heat is generated by the biomass is hitting only the tawa. And heat recovery, we have a small heat recovery vessel where we put water and we can heat indirectly a lot of food item that is there. Here we have a small chimney, which is the exhaust for this. Even during times, we can draw this as a hot water directly by putting a tap on this point. So this can act as a tawa and also a heat recovery hot water generator if a tap is provided here. Here we have a small ashtray which makes the whole thing clean. We pull this, all the ash is dumped outside. This is the ashtray here. We can see the demonstration of making rotis now in a minute. We can make up to 500 rotis by 2 people in an hour's time, and hardly around 10 kgs of biomass wood. 10 kgs, if it is purchased, it will cost around say 5 rupees a kg, 50 rupees. It is replacing roughly around 300 rupees worth of LPG every day. Rotis are being puffed. Puffed rotis are the sign of correct tawa design. And we can also have a heat recovery unit like this, where the waste heat is supposed to go to the chimney. We recover the heat here, and additional heating of cooked food can be kept here. We get hot water around 80 degrees. Heating of cooked food can happen here. We can use up to 5 kg of biomass at a time here, woody biomass. We can increase the burning rate or decrease the burning rate by adjusting the plate here. This is zero air supply for combustion. This is 100% air supply, and this is partial air supply. We can increase it, and also biomass gasifier, which converts small waste cut wood pieces into a gas. This is developed by TERI, the Energy and Resource Institute, New Delhi, who are doing a lot of research on a lot of biomass-based energy devices. This is one of the standard products developed by TERI. It is a very resourceful equipment where small waste cut piece wood is converted to gas, and this gas can be used for multiple uses. One of the uses is cooking. Wherever we get good resource of cut wood should be of this sized wood which has less moisture and size. This wood is put into the hopper through this top lid, opening the top lid. It comes in, it stores around 400 kgs of cut wood. It consumes 20 kg per hour of wood. Here there is an air blower which pushes the air in the reactor. Air blower pushes the air in the reactor. We have water seals. We have a burner at point of use. This has to be opened. This airport has to be lit. After lighting the airport, so yeah, next. This airport has to be lit. Once it lights, it takes 5-10 minutes for lighting this all 4 ports and making the gas stable. Once the gas is stable, every half an hour we need to shake this rod for cleaning the. We need to shake this rod every half an hour for the grate to be clean. So once the gas takes around 15 minutes to stabilize. Once the gas is stabilized, you get a flame like this. You get a flame like this, and you can cook your food on this. So from wood to reactor to gas. Can get consumed into our turbo stove, which has got a small power supply here, which has got 12-volt fan which will supply air to the required regions of combustion. Here primary air and secondary air is supplied at the correct positions. We can feed coconut waste like this and cook at a very economical cost. It works perfectly alright. We have a fuel refeeding door from all sides. Here we have fuel refeeding. We can feed fuel of this size as refeeding when the vessel is kept on the top. There is a grate shaker arm which grate shaking happens and it gets cleared. We have a small ashtray here which can be pulled and ash can be dumped outside. fuel. It will absorb so much of carbon dioxide which it releases during burning. Then the advantages is we need not cut the trees. We can trim the trees and use the fuel. We can use agro residues like coconut shells, waste wood. All the waste can be consumed. This is more or less at cost of wood and convenience of LPG. The advantages can be concluded.